Everybody, this is the beginning of chapter 4 for our Math to 11 geometry course in our geometry textbook. In chapter 4, we're going to talk about triangles and their congruent statements to prove that two triangles are congruent. This video will focus on section 4.1. So we're going to look at different types of triangles, how to classify triangles, and then find angle measures of triangles as well. All right. As you probably already know, a triangle is always formed by three non-collinear points and connected by segments. So a triangle has three sides. Each non-collinear point, each point in the triangle is called a vertice or a vertex if it's singular. And then the segments that join the points are called the sides of the triangle. Okay, and here is just a picture to show the different parts of the triangle. So again, remember, we have points A, B, and E, which are our vertices, or singular, they are vertexes. I think they're the vertex to the angle formed by the two sides. When you name a triangle, you put a little triangle symbol in the front and you name it by the three vertices. So you always want to include all three vertices. Order doesn't necessarily matter. If you're just naming one triangle, you could pick. So I could call this triangle BAE or EBA. You just want to follow them in order, which for a triangle, they'll always be in order. And then your sides, you just name them as segments. So we have segment AB, BE, and EA would be the sides. Here we have just a couple definitions. Adjacent sides are sides that share a common vertex, and we've talked about adjacent sides before. And then the side that is not adjacent to an angle is called the side opposite the angle. So for instance, if I had a triangle, so here's my triangle, and I'm going to name it A, B, C. Angle B right here, the side opposite angle B would be AC, so it would be this side right here. And sometimes what I do is I draw an arrow so I can find the side opposite. Adjacent sides would be something like AB and BC. They would be adjacent to each other. Right now, looking at triangle PQR, I want you to take a second again and pause the video. See if you can answer questions A, B, C, and D. And then once you're done, resume the video and check. Okay, so hopefully you paused the video. And we're going to answer the four questions. So they want us to tell them what angle is opposite segment PQ. So here is segment PQ right here. So the angle opposite PQ would be angle R. And again, you can draw that arrow if it helps. And let's erase that information. All right, next. Which side is opposite angle Q? So angle Q is right here. So the side opposite angle Q would be segment PR. Next, we need to know which side is included between angle P and angle R. So here is P and here is R. So the side included between the two would be, again, segment PR. And then our last question, which angle is included between segments QR and PR? So here is QR and PR right there. So the angle included, if you draw it, you can see it really quickly, is angle R. All right, there are two ways to classify triangles. You can classify them by angles and then by sides. This chart here shows how you can classify them by angles. We have 4 types of triangles. We have an acute triangle, which means that all 3 angles are acute angles, or if you recall, less than 90 degrees. You can have an obtuse triangle, which means one angle is obtuse, the other 2 have to be acute, otherwise it couldn't form a triangle. Equiangular means that all 3 angles are the same. And then a right triangle would be you have one right angle. All right, next we're going to classify our triangles by sides. And we have 3 different ways to classify them by sides. The first is you have a scalene triangle, which means that no sides are equal. You also have an isosceles triangle, and we're going to talk a lot about isosceles triangles in a later section. And that means that at least 2 sides are equal. And finally, if all 3 sides are equal, it is an equilateral triangle. So here they would like us to classify the triangle, and we can tell if we look at the triangle, we have a 90-degree angle because they marked it. So that tells us right away, if we classify it by angles, that it is a right triangle because it has a right angle or a 90-degree angle. And then if we classify it by sides, they didn't mark any of the sides equal, and they told us no sides are equal. And if we saw this triangle as it was and they didn't mark anything, then we would automatically go with no sides are equal. And it is, if it's no sides are equal, it is a scalene triangle. So then the complete name would be a right scalene triangle. All right, next, for our next triangle, if we notice, if we're naming it by angles, if we look at all 3 angles, we have a 69-degree angle, another 69-degree angle, and a 42-degree angle. So that means that all 3 are smaller than 90, so it is an acute triangle. If we look at the sides, I notice that I have 2 sides that are marked with 1 hash mark. So that means we have 2 sides that are equal, and that is going to make it an isosceles triangle. And I always have to look to spell isosceles. I'm not good at it. All right, so the complete name would be an acute isosceles triangle. Okay, here we're just going to mention the interior and exterior angles of a triangle. When we look at a triangle, we always have the 3 interior angles, which are on the inside. And then there are exterior angles if you were to extend out the line segments and make them lines. Now, there are always going to be multiple exterior angles to the triangle, but when we look at our triangles, we are always going to focus on just one exterior angle per side. And what I want you to notice here is if you look, angle 4 and the angle on the inside, they are going to form that linear pair. And then like B and 8 will form a linear pair, and 6 and the other angle on the inside form a linear pair. Here we have our triangle sum theorem, which most of you already know. All 3 measures on the interior of a triangle will always add up to 180 degrees. If it doesn't equal 180, it's not a triangle. So again, if you add all 3 angles, they equal 180. And what we're going to look at next is going to be a corollary to our triangle sum theorem. And a corollary is just, it's another theorem, but it's easy to prove as a direct result from a previously proved theorem. So we have our triangle angle sum theorem, and we're going to look at the next theorem that is a corollary of this because it's easy to prove based on this theorem. All right, our corollary here is the exterior angle of a triangle. And this is one theorem that we will use quite a bit in this course. And this theorem or corollary says that the measure of each exterior angle of a triangle equals the sum of the measures of its two non-adjacent interior angles. So here, angle 1 is always going to be equal to the sum of the measures of angles 2 and 3. They are the non-adjacent interior angles. And I want you to think about that. We know that angle 1, and if I just add in, let's put in a 4 here so we can see it. Angle 1 and angle 4, these two form a linear pair. They equal 180. We also know that all three angles in a triangle equal 180. So that means if 1 and 4 add up to 180, and 4, 2, and 3 also equal 180, that this angle right here has to be the measure of these two angles added together. It's really kind of a cool property. It makes sense, but we never thought about it before. Probably never looked at it like that. All right, we have one more corollary for this section, and this one talks about acute angles of a right triangle. So if you have a right triangle, the two acute angles, so the two angles that are less than 90 degrees, are always going to be complementary. And again, think about it, 90 plus 90 equals 180. So if one angle is 90, the other two have to add up to 90. So they have to be acute angles that are complementary. All right, now we are going to use our triangle sum theorem to find the measure of each angle in the given triangle. Here, remember, we know that all three angles will add up to equal 180 degrees. So, and they gave us the measure of three angles, but they did not give us what x equals. And so what we have to do is we have to find x to find the three angle measures. So the first thing we are going to do is add up all three angles. So I'm going to do 5x plus 6x plus 15x plus 24, make it equal to 180 degrees. I will combine like terms. So 5 plus 6 is 11x. 11 plus 15x would give me 26x plus 24 equals 180. Then we'll solve our equation, so I'll subtract 24 from both sides. I get 26x is equal to 156. Divide by 26. And x will equal 6. So then to find my three angle measures, I'm going to go back and plug in my 6. So if I do 5 times 6, that angle will equal 30 degrees. 6 times 6 will give me 36 degrees. And then 15 times 6 plus 24 is, let's see, 15 times 6 is 90. 90 plus 24, oops, will give me 114 degrees. And if you wanted to check further, add the three angles together, add 30 plus 36 plus 114. It will add to 180, and it does, so we are correct. Okay, next, we are going to find the measure of the exterior angle and the non-adjacent angles shown. So we have 3x minus 53 for the exterior angle, and we have our two non-adjacent interior angles. And remember, the sum of the two non-adjacent interior angles equal the sum of that exterior angle. So if I take x plus 67, it will be equal to 3x minus 53. We're going to solve the equation. So I'm going to subtract x from both sides. I'll get 67 is equal to 2x minus 53. I'm going to add 53 to both sides. And we'll end up with, that's 120 is equal to 2x. Divide by 2. So I get x equals 60. And so that means that this angle is 60. And then over here, if I do 3 times 60 minus 53, that means I'm going to have 3 times 60 would be 180 minus 53. And that should give me 127, which would be the sum of 60 and 67. So x equals 60, and the exterior angle is 127 degrees. And that is it for section 4.1. I will see you shortly for 4.2.